Today we're going to be talking about factoring a pair of numbers. And this goes right along with what we've been working with on the GCF and the LCM. And since it's called factoring, I think you can figure out which one it goes with. That's right, the GCF. So let's first start by looking at the two expressions we have here. The question is that is 4 times the quantity of 2 plus 3 the same as 32 plus 12? Well, let's take a look. According to the distributive property, if you multiply the sum of two numbers by a given number, which means you follow the order of operation, the sum of two numbers, 11, times a given number, because there's nothing between here that tells us to multiply it, we get 44. You will get the same result if you multiply each addend by that same number and then add the two products together. So this is the distributive property, guys. We are going to distribute or give out this 4 to everything on the inside. There are two terms in here. So we're going to do 4 times 8, and there's a plus sign, and then we're going to do 4 times 3. 4 times 8 is 32. 4 times 3 is 12. There's a plus sign. 32 plus 12 is 44. This shows how the distributive property is true and works. Generally, later on in algebra, you will be using the distributive property to show work this way. And you're going to say, why in the world do I want to do all that extra work when this is much faster? Well, you're going to need it later because there's going to be a variable in here. And that's going to change everything up. And remember, variables are letters that take place of an unknown number. All right, so for our purposes, factoring right now, we're factoring two numbers. And we're going to use the GCF. Let me show you how it works. I want to fill this out as we are working a problem because it just seems to make a whole lot more sense to fill it out as we're working a problem out. The directions say factor each to write an equivalent expression. Well, you know, equivalent means equal. An expression is still a math problem. So that tells us do not solve. They aren't asking you to solve it. They just want you to write an equivalent math question. Okay? All right. So to do that, we're going to find the greatest common factor, and I've shown you how to find the greatest common factor using the bobsled. So we're going to put both numbers in the bobsled. Some of you can look at this and automatically know the greatest common factor for the two. I'm going to not choose the greatest one on purpose to show those of you that haven't seen the bobsled before how to use the bobsled when you don't pick that number right away. We do need a number that goes evenly into both. Since they're even, we know 2 will work, but you want to try larger. The larger the better. 3 would work. 4 works. So we could keep going, but I'm going to go ahead and use the 4. And then it's like upside down division. 4 into 24 is 6. Bring down that plus sign. And then 4 into 36 is 9. We keep going until the only number we can divide by is 1. What number goes into 6 and 9? Evenly. That's right, 3. 3 goes into 6 twice. Bring down your plus. 3 goes into 9 3 times. The only number that goes evenly into 2 and 3, that is a common factor, is 1. 1 is not going to help us. If we divide, we're going to end up with what we had to begin with. So that lets you know you can stop. And the GCF is on the left. Made a little chant about that. So what you have to remember, though, is you're going to multiply the numbers on the left. So 4 times 3 is 12. All right, so we're going to find the GCF of the numbers. Now, we did that. Second step, you're going to write the GCF outside the parentheses. So that means you're going to put parentheses. And the next step says to write the numbers at the bottom inside the parentheses. All right, well, the bottom of your bobsled is right here, so you write 2 plus 3. And I'm going to move this over because that bothers me. Okay, now, we're not solving it. This is an expression, and now we can double check with some mental math to see if it's equivalent to what we started with. And we can do that by applying the distributive property. So 12 times 2 is 24, and 12 times 3 is 36. So that lets me know this is how you factor 24 plus 36. Isn't it cool? I just love it. Okay, look at the next one. We have 18 plus 3. And again, I want to reiterate, the only way that the distributive property will work is if there's a plus or a minus in between the two numbers. Okay? The distributive property does not work for multiplication or division of the two numbers. Okay? All right, so let's divide. What goes into 18 and 3? I hope you said 3. That's correct. 3 goes into 18, 6. Bring your plus down. 3 into 3 is 1. Can anything go into 6 and 1 other than 1? Nope. So that says our greatest common factor for these, the common factor for these two would be 1, and we're ready to calculate the greatest common factor for the numbers in the problem. GCF is on the left. Since we only have one number, you just bring it down. Now it says, we did that. You're going to put some parentheses. Write the numbers at the bottom inside the parentheses. So here is the bottom. 6 plus 1. Do a quick mental math check. 6 times 3, 18. 3 times 3. Sorry about that. That was my dog. I got a good watchdog. All right, let's try one more together. We have 6 plus 21. Put them both in the bobsled and ask ourselves what goes into 6 and 21. Well, 2 goes into 6 but not 21. 3 goes into 6 and 21, so that is what we're going to use. 3 goes into 6 twice. Bring down a plus. 3 into 21 is 7. What number goes into 2 and 7? You're correct. It's just a 1, so the common factor for these is 1. We're going to stop because if we divided, it wouldn't give us anything different. All right, the GCF is on the left. Again, it's just one number. Just so happens it has this 3 like before. Then it says we're going to write our parentheses and bring down what is ever left at the bottom. Quick mental math check. 3 times 2, 3 times 7. Now, sometimes people don't use the greatest common factor and it would still work. For instance, if I stopped right here, I would have written 4 parentheses 6 plus 9. And then 4 times 6 is 24, and 4 times 9 is 36. So the quick check will work even if the problem's not right because you didn't use the greatest common factor. So be sure you're making sure that that bottom row of numbers can only be divided by 1. All right, so let's take a look at a couple more. Here we have a subtraction problem. You do it the same way. These numbers are a little larger, so we still work it out the same way. All right, well, with big numbers, you want to try a big number first. Always try the smallest number into the biggest number. 39, I don't think it goes into 18. Into 78, so, because we don't know our 39 tables. Well, that's not going to work, but we do know that 39 is prime, so the only numbers that can go into 39, oh, it's not prime. It is not prime. What can go into 3 and 9 evenly? 3. That's exactly right. So now we want to see if 3 can go into 7 and 78. Well, the divisibility rule for 3 says to add the digits together. So 7 plus 8 is 15. And 3 does go into 15, so that tells me that 3 goes into both of those numbers. So I'm going to put a 3 out here. Now, 3 into 78, some of you might need to come down here and do the division, and that's perfectly fine. I don't want you to make a careless mistake doing the mental math. So that would be 1 left, 18, 6. All right. So this would be a 26 minus 3 into 39. Oh, well, look at there. 26 minus 13. Well, we got another problem. You might think nothing goes into that because 2 doesn't go into both. 2 will go into this one because it's even. 3 can't go into either. 4 doesn't go into either. 5 doesn't go into either. 6 will not go into either. Guys, when you have a prime number in here, you need to check to see if the prime number goes evenly into the other number. And in this case, it does. We're going to divide both numbers by 13. And 26 divided by 13 is 2. You bring down the minus, and 13 divided by 13 is 1. Now we're ready to go. We're going to get the GCF, which is on the left. Some of you might need to come down here and do 13 times 3, which is perfectly fine. I don't want you to mess up. Oh my gosh, look. 39 would have gone into 78. That's amazing. Put your parentheses, bring down the bottom, and that is your equivalent expression. Remember, we're not solving because we want just an equivalent expression, which is another math problem. All right, I want you to do 5 through 9. Come back after you pause the video and see how you did. All right, so here are the next ones that you could do that I asked you to do alone. Be sure that you don't get confused. If you divided by 3 first and then divided by 7, you still would get 21. It doesn't matter what order we multiply in. So that's why the commutative property helps us out there. Pause the video at any time if you need to correct your work. I do want to talk about number 7. It says to find and explain the error. Well, the error is that 2 is not your GCF. 2 into 60 is 30, and 2 into 84 is 42. But these are even numbers, so that lets me know we could keep dividing at least by a 2, if not something else. So that would be the error. Yes, this is an equivalent expression, but it's not factoring. When you factor, you use the GCF and not just a common factor. Here are the answers to the last 2. Pause the video if you need to, and hope you did well with this and learned something new.